Hey Global Impact students, this is Mr. Ellinger. This lesson is on solving proportions. Our learning target for the lesson is we want to be able to solve and apply proportions. Essential understanding for the lesson is a proportion is an equation that states two ratios are equal. Also, if two ratios are equal and a quantity in one of the ratios is unknown, the unknown quantity can be found by writing and solving a proportion. So what is a proportion? Well, like it said, a proportion is basically two fractions equal to each other. So in general, A over B equals C over D. We call that a proportion. Okay, A, B, C, and D are numbers. Now, proportions have a property. It's called the cross products property of a proportion. So the cross products of a proportion are equal. If we have A over B equals C over D, okay, B and D can't equal 0 because they're in the denominators of fractions. We know we can't have that happen. Then AD equals BC. There's our cross products. So, cross products meaning if I take A and multiply by D, that's a cross product. If I take B and multiply it by C, that's a cross product. Okay, cross products, diagonal multiplication, and there's an example. That's how we solve a proportion. So here's some examples of solving proportions. First one, we have 3 over 10 equals y over 5. It's a proportion, one fraction equaling another fraction. We have an unknown value in that proportion, y. So what we're going to do is we're going to cross multiply. We can multiply 10 times y, that's 10y. And we can multiply 3 times 5, that's 15. So what we've done is we've taken the proportion and we've turned it into a fairly simple equation that we can solve. Divide both sides by 10 and y equals 3 over 2. And in this case, it would be okay to put 1.5 because it's a terminating decimal. All right, second example here is a little more complex proportion, but we still have a proportion. We have one ratio equaling another ratio. So again, we have this cross product property that says if I take this numerator and multiply it by this denominator, it's going to equal this denominator times this numerator. But the key here on these, the tricky thing is this b minus 8 has to be treated as one quantity. The b plus 3 has to be treated as one quantity. So when we go to cross multiply, 5 times this quantity b plus 3, we have to write it just that way. 5 times the quantity b plus 3. And we have to multiply or write 4 times the quantity b minus 8. Because that's what's happening. Distribute 5b plus 15. Distribute the 4, 4b minus 32. I have b's on both sides, so I'm going to collect my b's on the left. This gives me a 0 here. 5b minus 4b is 1b, or b. Bring the 15 down. Bring the negative 32 down. I'm going to subtract 15 from both sides. I get a 0 on the left, leaving just a b. I get negative 32 minus 15 is negative 47. Okay, so there's my answer. Now, it's always a good idea to check our answers. Sometimes when we get an answer like negative 47, you might say, man, that's kind of large. I don't know if that's right or not. So we can check. Negative 47 minus 8 over 5 should equal negative 47 plus 3 over 4. Negative 47 minus 8 is negative 55 over 5. Negative 47 plus 3 is negative 44 over 4. These both reduce down to negative 11. So that is our answer. Okay, here's an application of proportions. An 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of orange juice? We have a ratio. We'll take our 8 ounces per 97 milligrams. We have a 12-ounce can, and we want to know how many milligrams vitamin C there are there. So I'll just call that X. And I don't need my units in here, but it's maybe helpful to set up the proportion. Anytime you're setting up a proportion for word problems like this, the quantities, this is the way I do it. I always make sure that my same two quantities, ounces are in the numerators, milligrams are in the denominators. So I would go ahead and cross multiply. 8 times x is 8x. 12 times 97 is 1,164. Divide both sides by 8. I get 145.5. Again, going back to the problem, this is not enough right here. It's not enough to stop right here. The problem says about how many milligrams of vitamin C are there. I have an answer of 145.5. That is about, if I were to round this one, I would round it to 146. So I would say there are about 146 milligrams of vitamin C in a 12-ounce can of OJ. Answer the word problems. Okay, so another application of proportions is when we get into what are called similar figures. In geometry, we'll talk more about similar figures. Similar figures involve what's called a scale factor, and that scale factor can be used to convert different ratios of sides and things. And the scale factor can be used to set up proportions. So here we have a science application. A giant model heart is shown below, 14 feet tall. It is giant. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? This is what we're trying to find, right? The size of a heart, that's our X. 6-foot man. Over here, our giant model heart is 14 feet, and that is for a 170-foot tall person. Now, obviously, that is completely unrealistic. This huge model, this is built somewhere, okay? You can see over here in the corner we have a railing coming down some steps. So this is some model somewhere in some museum or science museum or something. The proportion here though is we're going to put the height of the giant heart over the height of the man's heart. So here they're writing a ratio of the two hearts equals the height of the giant person over the height of the man. All right? So this is a little different than what I mentioned in my last example. If I were going to do this, if I were going to set up this proportion, I would put giant heart over giant man, and I would put regular heart over regular man. Okay, and the question is can I do that? Well, if I follow the example here, if I plug in the values that I know, the giant heart is 14 feet over X, my unknown. The height of the giant person is 170 feet over the height of the man, which is 6 feet. Cross multiply, divide. I get X is approximately 0.49. So the size of the man's heart would be about 0.49 feet. Well, if I were to set my proportion up this way, my giant heart is 14. My giant man is 170. My regular heart is my X, and my regular man is 6 feet. I'm not going to do this to completion, but if I just look at the cross products here, 170 times X is 170X. 14 times 6 is 84. Look at the cross products. They're the same. So the point of this is that when you're taking a word problem like this and you're writing a proportion, there's more than one way to do it. But however you set up one ratio, you have to follow the same formatting in the other ratio. Here I used the two hearts and the numerators of those ratios, or the tops of those ratios, and I used the men's height in the bottom. Okay, as long as I stick with that. I couldn't flip one of these over. I couldn't have giant heart over giant man equals regular man over regular heart. That wouldn't work. Here, over here, the way that the worked out example was, the height of the giant heart and the man's heart. So they have the ratio of the two hearts and the ratio of the two people. Either one of those would be acceptable. Okay, we just have to make sure that we're following some type of system when we set up these proportions. Very critical. Have a great day, folks.